Alright, so a summary of what we did as a group. The first thing we did was we met as a group at the library to discuss some of the different things we were going to do to approach the first project, such as what we're going to use for a mousetrap car and our technical documents and such. Unfortunately, we found out at class that our mousetrap car was unacceptable, so we ended up ordering one on a physics website you had suggested to us. I can't remember the name of it, but it came in the mail a week later, so we were able to get together during the break or the day we didn't have class, to build it and test it. So that went pretty well. We built the car in about an hour or two, and we were able to test it, and it worked, which is a plus, usually is. And it was cool to see, it was cool to test it and see what we had been working on for like 2 hours finally be built and working. And then after that, we discussed some of the different physics topics that related to our mousetrap car and discussed how we're going to use it in our technical document and in our Digistory.
Okay, so now I'm going to talk about displacement. It's one of the elements that we had to incorporate into our first project, one of our physics concepts. So displacement is a vector quantity that's measured by a numerical value as well as the direction. So we determined from our Excel data and our logger pro analysis that our car was displaced 4.45 meters. Since displacement is the final position minus the initial position, this is how we came up with that quantity for the displacement. And it was 4.45 meters rightward.
Alright, so acceleration can be described as the rate at which an object changes velocity. It's measured in meters over seconds squared. So therefore, if an object is accelerating, it's changing velocity. In the case of our mousetrap car, it was accelerating from the beginning to about halfway when the mousetrap was propelling it. Its velocity was increasing, so it was accelerating. And then after that, when friction started working on it and gravity and the force of the earth was slowing it down, the velocity was decreasing, so then the acceleration went from positive to negative.
I'll be talking about Newton's 3 laws and how they relate to the mousetrap. Newton's first law is that an object at rest will remain at rest unless acted on by an unbalanced force, and an object in motion continues in motion with the same speed and in the same direction unless acted on by an unbalanced force. How it relates to the mousetrap is that the mousetrap car would stay at rest indefinitely unless it's acted on by an unbalanced force, and when it was acted on by that force, it would stay in motion forever unless it was acted on by an unbalanced force as well, such as like a wall or friction. Newton's second law is that acceleration is directly proportional to the force and inversely proportional to mass. So that's A equals F times M. This was related to the mousetrap car because if you change the acceleration of the car, then the force will also change, and that is also true about mass. Newton's third law: for every action there is an equal and opposite reaction. When the car was rolling, it has the reaction of moving forward. Friction, on the other hand, is moving in the opposite direction, and eventually the force of friction evens out, which shows that for every action there's an equal and opposite reaction. And that is Newton's 3 laws.
Then I'm going to talk about Hooke's law and how it applies to our project, the mousetrap car. And Hooke's law is basically the extension of a spring is in direct proportion with the load applied to it. So I guess how that would apply to our car is with the mousetrap's arm, how it propels the car with the string. So I guess the force that would be applied to the holding the arm down is the string wrapped around the axle. So then what makes it go is when you release it and it rolls on the ground and it slowly snaps back into its original position. So it's an equal reaction to the axles releasing the string, because just as much as the string is being let out, the arm is being set back into its original position, which is then causing the car to move.
Okay, so issues that we had with the project. We really only had one major one. We didn't realize that the mousetrap had to be attached to the car, not only motivated by it. So we got a little bit of a late start, but we built a working model and it actually runs pretty nicely. Another issue that we had was in the actual construction of the car. We didn't have the appropriate tools, so we should have been a little bit more prepared on that. But, you know, it's the first project, so we'll work through the kinks and we'll make everything okay. We actually didn't have scissors or super glue, so like I said, we kind of just worked through that and built a nice little working model. So those are really our only issues.
First of all, I guess what we can do better next time is just ask a few more questions for the overall project perhaps when we weren't exactly sure on what was clear, what was expected of us. Just ask more questions and not be worried about that instead of, you know, just assuming we know what we're supposed to be doing. We kind of got set back a little bit because of that, I think. We were able to work everything out, but I think for the next project it will be good to just make sure that we're really clear on what is required of us and what is expected of us so that we know exactly what we need to do to complete the project the way it is expected of us.